things I forgot to mention on the histology part is, remember how I talked about H&E, and we did the first study, and those were longer exposure times for H&E, and then the second study we did shorter exposure times using H&E, and it seemed we had better results. The other thing to remember is just don't use any old hematoxylin. You have to use specific Myers hematoxylin. Don't use any of the other types. Because I actually don't know the chemistry, but there are problems, and it's in the literature, some of the other types of hematoxylin affecting your downstream analysis. In addition, what we noticed when we were just talking over there is the nuclear fast red you guys were using there. One thing I know, it was brand new and fresh, and we noticed it looked a lot better than in our labs. And we were just talking about, well, we have to be careful about how long these stains are sitting around or monitoring the pH and such, because you got your cells look better than mine, and maybe I had my bottle sitting around for a long time, and over time it was just kind of getting less intense of a staining. Something to keep in mind, especially since the ID and the dissection is a critical part in this process. Okay, so then just continuing on, we did a comparative study. So how does laser microdissection perform versus a preferential lysis method like differential extraction? Because that's what most people are using. So what we did is we had a study where we made artificial mixtures of sperm cells and epithelial cells. And on the top here, we made, here on the first it says 1 to 5, so 1 sperm to 5 epithelial cells. And we went all the way out to 1 sperm and 160 epithelial cells. We had actually done hemocytometry to our pellets to actually count all our cells and make sure we had these mixtures. So on the left is what the flow of the LMD samples, and on the right would be the differential extraction. So from that one pellet of cellular pellet, we used 9 microliters. Like you did yesterday, you made 3 spots of 3 microliters on each spot for the LMD. And then we collected 20 to 30 sperm cells, and then used the lysin go extraction. And again, we used nuclear fast red staining. Then, though that extract was immediately amplified, PCR master mix was added directly to the tube, and then it went on to CE. For the preferential lysis study, and we didn't do this in-house because I have done a lot of differential extractions, but it had been a while, and I wanted someone experienced to do the differential extraction in a routine environment. So I actually had a forensic lab. We sent these to a forensic lab who does differential extractions routinely, and they ran it through their normal protocol. I gave them 25 microliters of that pellet, and they performed a differential extraction. Theirs involves an organic purification and a centricon. And then we also took that extract and did a qPCR to make sure we had enough DNA. And then when they did their protocol, it ended up that we needed to add the maximum amount of extract available. So some of the samples were right at about 2 nanograms of input, and some of them were way below that. And these were all done using low copy number techniques, 34 cycles. Oh, and be aware that even though we had a forensic lab do the preferential lysis study, it all came back, and we did the amplification together and the CE together, so that there was no variation in that. So let's look at the easy one first, a 1 to 5 cell mixture, comparing LMD on the left and a differential extraction on the right. And if you look, they look about the same. We got similar results at a 1 to 5 cell mixture. Each performed similarly in its separation capabilities, getting a full male profile. And that's not unexpected. In literature, with doing a differential extraction, you should be able to separate the sperm. Now let's move to a 1 in 160, the extreme. So LMD, you get a full male profile, and actually very similar to the previous page of a 1 to 5. So same results, but if you look at the differential extraction, we have a different story. The circles represent female carryover from the epithelial cells. And then the arrows actually represent dropout of the male alleles. So you can see that the performance of a differential extraction when the epithelial cells are much higher in concentration, it's a very poor separation and detection also. So looking at kind of the whole range between a 1 to 5 mixture and a 1 to 160 mixture. Get the pen. So if you look on the top, ideally you want it to be 100. That would be the best performance. And the laser microdissection method are in the red squares, and you can see all across here that there's very good performance, close to 100% of the male alleles detected. But looking at preferential lysis, it performs well in a 1 to 5 and a 1 to 10 mixture. But as the density of epithelial cells increase, you could see at the 1 to 20 and the 1 to 40, it starts going down, and then the performance drops off as the density increases. So this right off the bat, you can see how consistent the separation ability of laser microdissection is. Okay, so that was the male alleles. What about carryover? I'm sorry, let me say on the last slide, it's not so much the separation capabilities, it's detection, their sensitivity. Now we're looking at separation capabilities. So with the female alleles, ideally you would want to see 0. And with laser microdissection, on all the samples that we tested, you can see all the red boxes are down here. No female alleles were detected in all the samples, even at 1 and 160. But with preferential lysis, okay, 1 to 5 it was okay, 1 to 10, 1 to 20 was okay, but then you start getting into higher densities, and you have a mixture seen in your profile. So just to kind of go back a little bit, remember the male alleles, you get very good detection of male alleles using laser microdissection, but it drops off for a preferential lysis separation about 1 to 20. And then with the female carryover, laser microdissection has good separation throughout, but preferential lysis drops off starting at about 1 to 20. So this is actually, if you look in the literature of differential extractions, this is fairly consistent with those ratios. You started losing its ability to separate and detect the male fraction. So I think those particular 2 slides are kind of powerful in showing the ability of laser microdissection. This is just another way of looking at the data in terms of amount of PCR product of laser microdissection versus a differential extraction. At the 1 to 5, you have about the same amount of PCR product, either method you use. But as you go have a higher E cell density, you start losing the amount of PCR product of the sperm fraction that you have. And the asterisks indicate that's actually a significant drop using the differential extraction. So comparing kind of a workflow of the 2 methods, at least the methods that I use. So preferential lysis method, and some of this might be a little outdated because I know there's some more new techniques available. So you do a microscopic ID, and then you do a preferential lysis separation, which takes 3 or 4 hours. I know there's some automation, which of course that does speed up tremendously the process. Then you have a DNA isolation. It could take up a couple of hours. And then you have that dreaded quantification. I don't know how long is quantification take. I don't know what techniques you're using for quantification now. Are people using qPCR pretty regularly? How long would you say that process takes for a batch of samples? What?
Less than 2 hours.
Okay, so that's kind of outdated. So it's less, but it's still a process you have to have in there currently. And then you go on to do your PCR. For the laser microdissection method, you do your microscopic ID and, of course, your collection at the same time. And you could gauge by yesterday about how long it might take you to do that. And the 5 cells a minute was kind of my old, what did you time them yesterday, didn't you?
Yeah, I mean, we had someone cut at 75, or I don't know what the other groups did, but again, that was like 11 minutes.
Yeah.
Again, that's even with having to cut the hanging chads, and
right.
I mean, it was fast. I mean, when I was cutting 75 on our microscope, it was a good 30 minutes, if not longer.
Okay.
But still, that's quick.
Yeah. So. This is kind of my old speed here.
Yeah.
And then the method that I use, that you guys use and I use, is the Lysengo, which is really quick, 20 minutes. But obviously, it'll be whatever method you use in your isolation. And then right to PCR. So you can see the actual workflow is much shorter for one sample. So If you're batching, that's the only thing at this point. There's not really batching using the LMD method. You can't separate all at the same time like you might in a differential extraction. But certainly for one sample at this point, it is actually a faster process and fewer steps of manipulation. So in conclusion with the comparative study, the laser microdissection method provides an improved separation and detection of the sperm from epithelial cell DNA over a differential extraction, particularly at these higher E cell to sperm cell ratios. And LMD doesn't require the quantification step. And so single sample processing can be more rapid using the LMD. And maybe as things get more automated, especially if you use the process I do for the extraction where everything's in one tube, really you could batch all those tubes and have the whole process done in an automated fashion. And hopefully we'll see today some like new auto recognition software which may even speed up sperm ID. Okay, so now I'm going to talk about case studies. Now, I'm going to warn you ahead of time. This is we only had a few cases to work with, and when we did the study, we ended up adjusting some of our protocols, so it's not ideal in its tests to determine whether LMD is good for casework. But there's some interesting things that we found. And my suggestion is that a forensic lab with lots of cases needs to actually do a full-blown case study. We only had 4 cases available to us. So we had 4 cases. These were from non-probative or adjudicated cases. They originated from a crime lab that performed a differential extraction and did 13 core loci in the original case. The first case was just a public masturbation, and there was tissue paper recovered from the scene. That seems like a pretty easy one. Then cases B, C, and D were sexual assaults where we had vaginal swabs. Now, case A, there was lots of sperm, and we collected 30 sperm cells and did LCN analysis. Now, we didn't, in this one, there's so much sperm we really didn't need to, but we want to kind of mimic a low copy number scenario. So we only collected 30 sperm. And case B, C, and D, well, these were difficult. And we had very limited sample because they were already had been analyzed, and there was very little cotton swab left, so we couldn't really even do a second extraction to try to get more cells off the swab. And so what we ended up doing, because we couldn't really find any sperm, and some of them they even said were difficult samples, we ended up modifying the protocol. And someone just talked yesterday about what do you do when there's just tons of epithelial cells and you can't see the sperm. And you know that it's just a problem even normally if you're trying to ID sperm. Well, one of the things that Kelly suggests is perhaps doing a more dilute smear. That might work. We, in this case, actually kind of did almost a cheat and did a mini lysis. So it kind of added a little preferential lysis in there by doing a very mild lysis of the cell pellet for just about 15, 30 minutes at the most, and did just one quick wash, just to get rid of some of the density of epithelial cells. So it took us about 30 minutes to do that little mini lysis, and then we smeared it onto the slide. And then we collected, and even some of them we even didn't even have 30 sperm. There were so few sperm on these slides. So it was, in a way, it was good for a low copy number test. So we did 18 to 30 sperm, and it was interesting. After we did that wash and put on the slide, then I could collect the sperm in just a few minutes. It's like no problem. It's just there were very few available. And this is why I'm saying that this is not an ideal test, because we did modify our original protocol. All right, I'm not going to go through the entire thing, but you have this in your notebook. Hopefully you can read it. If you want to see this in more detail, again, I have a website that'll direct you to that has this. So this is, we'll just quickly, case A. Case A resulted in very similar results to the preferential lysis. That's not no surprise because it was a tissue paper which pretty much neat semen stain on it. Case B, I'm going to come back to that. So we'll just move on to case C. If you look at case C, you have, let me do the highlighter. Case C, this is the LMD results. And then next to it is the differential extraction results. So you can see in the original study, they got definitely a partial profile. But when we did this modified at LMD, we got what appears to be a full male profile, and no apparent mixture at least. We didn't have a female fraction to compare to. Oh, yeah, we did actually over here, but we didn't. It didn't seem to have any mixture. And actually, this KC victim isn't an exemplar. That's kind of an assumed profile from the preferential lysis, the differential extraction they did. So in that case C, we actually had improved results. That was good news. Case D, that was another story. So if you look at the case D original preferential lysis results, they have a pretty good profile. Some drop out. But when we did our LMD, we actually got worse results. So this was the one case we actually had poorer results than the original case. But case B, so far we have case A, similar results, case C, better results, case D, worse results, and then case B is actually better results. So we have 2 good, 1 same, 1 bad. Again, it's a very little small study. If you want to take a closer look at B, I actually there's another column of data here just to show you what happened before I did the mini lysis. This is the original results from the sperm fraction. It was a clear mixture between the female and the male on the vaginal swab. And the first time I did this, I just collected 10 sperm. This is before the mini lysis. And I had such a hard time getting the sperm that I could barely find 10. And I had just gotten a partial profile. After the mini lysis that I performed and did laser microdissection, I got almost a full profile. Let me look at my notes. Okay, so if you look at far on the right, the 30 sperm cells, the samples with the 3 asterisks, those are the ones that an allele dropped out of the male profile. So a nearly full profile. But what's nice is that I also just got the male profile. So you kind of have to make a determination. Was it better to have this big mixture here using a preferential lysis? Or would you rather have just the male profile with a couple drop out? And how is that information value? I think it's better to have the just a couple alleles drop out in the male profile, but have that separation. So in my mind, I think these are improved results. Yeah.
I think as far as if you were, again, doing casework and you were doing a statistical analysis, absolutely. Okay, those results are better. It depends on the lab's policy. Some people do a deduction of a mixture, where they deduce a major profile because if it's an intimate sample, they essentially take out the female contributor peaks if there's a major male profile present, and then they'll do a statistical analysis on that. Okay, that might be larger as far as your statistical number or rarity of that profile. But I think that your clean type over here on the right, even though you have a couple peaks drop out, that still is extremely valuable statistically.
Yeah,
and easier statistically.
Right. And it's clearer to explain, really.
Yeah. I think the only thing that's a problem, though, you have the 10 sperm and you have that 13 showing up.
Yeah, I know.
Would have eliminated it.
And I put a little asterisk there because I was getting a really low profile, and I said, "Wow, is that coming from the female?" It's hard to tell because is that 13? Was it something else at the low copy number level that was just you had this 13 peak show up, or is it from the female? I mean, it's really hard to say actually. But again, it's something to consider. Now we're dealing with real casework here. Okay, these were difficult samples.
I'm sorry, can I make a comment about that too? Again, yes, we don't know where that 13 is coming from. However, there are ways to do statistics on low copy number profiles where you take into consideration the fact that there might be a second peak there. You don't know if it's a homozygote. I think there are ways that you could do statistics on that 10 sperm profile that would still be useful. Yeah, your number is probably going to be a lot lower. I mean, because that's a more conservative way of doing statistics. If you were to do that type of a statistical analysis.
Yeah.
But yeah, so that's a little different,
Right.
I guess.
So with this in mind, again, I kind of said this before. What was the performance in this little mini study? One case very similar to preferential-lysis, 2 cases improved results, in 1 case worse results. And again, was such a small little study. We really need a large-scale study to evaluate this. But I think it's promising to see that you can get improved results. And again, this is the reason why we changed. We have low copy number issues, and we did that mini lysis. So it can't be an exact test for the laser microdissection. We need a larger case study population. Hopefully one of the forensic labs will do that side by side. Okay, and so I just want to put this through, kind of the research team at Rosalind Franklin University, myself, Dr. Peterson, who I couldn't have done this without him, and my lab tech, Emily, was wonderful. Nick Sanchez at LIPD, he was the one, before I had any money at all, he did a lot of my capital electrophoresis, and that was great. And Jack was my thesis advisor at University of Central Florida, which was very helpful. And then also Kenneth. Kenneth Foster, he's that lab, I don't know if you know, it's a teeny little lab in northern Illinois. I lived in Illinois, in Chicago area, for 2 years before I realized there was this teeny little lab just a few miles from me. Because everyone thinks Chicago, they think the big state lab. But Kenneth actually did all the differential extractions for the study. And I put this last slide just there because, does anyone know what that image is? It's graphically enhanced, but does anyone know? Is that
X-ray crystallized.
Yeah, it is. See, some people don't know. That's the logo of the university, because Rosalind Franklin is the one who took that image. So, any questions on this? Let's see where we're at here. And I think so. What we're going to do, and we're actually now running on time, believe it or not. Pat is going to give the next talk.